Hi everyone, thank you for spending the time to watch this presentation on DataOps. My name is Lars. I run a small company based in Stockholm, Sweden. The name is Kling, and we build and run customized data pipelines on behalf of our clients, and I will tell you more about that at the very end. We are essentially a company built around DataOps, and I've been doing DataOps for a long time now. My history on the subject dates back to 2013, where I was part of the data platform team at Spotify, and we decided that we needed to enable more teams to make use of data. There was just a few teams that were capable of using our data platform data lake, even though it was quite large at the time. And we wanted to enable every developer team in the company to make use of data and to innovate based on data. So we made a transform on how we work with data, and later we learned that it had a name, DataOps, but it didn't yet have a name at the time. We never managed to, at the time, to explain to the world what we were doing and how we did it. And I tried to do so in 2018, but the concept was still unheard of, so the conference proposal was rejected. And back in 2 years ago, in 2019, I held as far as I know, the first presentation on DataOps in Scandinavia, and that on the Data Innovation Summit, and that turned out to be the most watched talk among the recordings. And now we are here 2 days later, and we have a whole day dedicated to DataOps. So it has really risen on people's radars. And why would you want to spend your time on that? Well, one of the proudest moments in my career was when I realized that Discover Weekly was built 1.5 years later after our transform, and the people that built it held a presentation, and they said that we were able to build this thing, just a few people in a few weeks, and launch it in a few months, because there were so many things that were already available. There were data sets out there that we could reuse. There was the infrastructure, and people had curated the data sets and so forth. So it was all very simple to innovate, and this was precisely our goal with the DataOps transform we made. Now, this level of innovation is not available to most companies, but that is sort of the ultimate goal, more or less, of adopting the practices of DataOps. We're a good example of the ultimate goal. So what is DataOps? DataOps is about turning what used to be a craft into turning that into a factory, and from a manual working process with your hands to a automated factory process. And we see this in lots of places in IT. We see it in infrastructure, where we move from pet servers to infrastructure as code. We spin up in the cloud on demand, from waterfall to agile and release processes, where we used to build the precious release 2.0 and give it to QA, who would validate it and so forth. And now we have continuous releases and continuous quality assurance processes. And for data, this means that we have gone from the database-oriented architectures in the past with mutable, precious data, mutable data, where we carefully crafted code, and if something went wrong, it was all destroyed, and we had to spend lots of time recovering from it, to pipelines and data factories, where we store the raw data and we do transformations but never touch the raw data, so that if things go wrong, we can rebuild the data sets and do it all again. So if we take one of these processes and look at it naively, we see that it's we take the raw data, we turn it into some kind of valuable data. And this is what analysts do all the time with their hands, with their Excel sheets and so forth. And this only takes us so far to do by hand. So in a mature data environment with mature data pipelines, they kind of look something like this, where you have the raw data, and you not only refine it, but you also improve the data by curating, deduplicating, mending broken data, bringing in additional data sets to cover up for the missing pieces and so forth. And you monitor the quality to make sure that the incoming data is of good quality, the outgoing data is of good quality. And if you have complex things like forecasting to cater for late data and so forth, you do several variations and measure how they perform and so on and so forth. So this is, in data mature companies, this is a typical pipeline, but you have to be efficient in order to be able to manage this level of complexity. And this is absolutely crucial to be able to do in order to get sustained return of investment from machine learning. Because lots of people have the impression that machine learning goes something like this, that you take the raw data and you build a model and then you throw it out into production and then you're done. You can move on to the next thing. But in reality, valuable machine learning models look just like these complex pipelines, and where you need to curate things and you need to monitor how they perform and monitor that both ingoing and outgoing data is still okay and so forth. And there's a quote here from Eric Bernhardsson, who made some of the first recommendation implementations at Spotify, and he points out that the value is really in this plumbing all around, not so much in the models. And in many cases, you can just have just the plumbing and not have a model, and just have a human instead who is informed by all of the data, and that can very well outperform machine learning in many cases. So how do we learn to do this well? Well, we've created data factories. So we look at the experts on factories, and Toyota is who sort of invented the lean process, is the obvious shining star here. This is the book that has had the most profound effect on my career and the way I work, and it was really an enlightening read. All of the principles mentioned in there are directly applicable to IT. I will mention a few of them, but the one that I will concentrate on most here in this presentation is waste, because we have so much waste, and therein lies the great potential. There are different species of waste out there in data processing systems. There's cognitive, things that we humans need to keep track of, technology, delivery, operational, product, and so forth, which I will go through in a moment. And what I found is that companies tend to be good at one or two of these forms of waste, but could be completely blind to other forms of waste. And in that blindness, there's a potential. Because if you can learn to see new forms of waste and address them, you can significantly improve. So let's look at them. Cognitive waste usually comes from entropy. There are too many different things. There are different ways to store time, or different ways to name things, or different definitions of orders or users or items and so forth. And this makes it complex and slow for us to move along. And one of the common forms of cognitive waste is the sprawl of code and documentation all over the place, where you have the same code duplicated in multiple repositories, old copies of repositories that somebody forked a year ago and that now turns up in your code searches, or documentation with notes from 3-year-old meetings and so forth, rather than just the actual stuff that is here now, which would be a lot simpler for you. So how does it appear? Well, it grows organically. It grows all the time. As soon as we do things, the entropy increases and all of the waste grows. And also, it depends on your culture how fast it grows. If you have give lots of freedom to people and have autonomous teams that can choose whatever in how they work and the processes they pick and the technology they pick and so forth, the waste increases. And also, if you reward throwing things out without looking to see, has somebody already done this? Can I reuse something? Then you can, in an environment such as that, you will have more waste. So how do we avoid it? Well, we spend the time to reuse things, and we make it easy to reuse things. And in order to reuse, we must be able to find the things that we can reuse. We must be able to find the codes, the definitions, and so forth, and read them and understand them. And we must also be able to change them, to adapt to our needs, and to fix what's wrong. If we have dove into something of relevance and understood it, and we see that something's wrong, we need to be able to fix that so that it improves for the next person coming along. But in order to do that, you need to feel very safe that if I change something in sort of code that I'm not comfortable with, I can verify that it works and doesn't break anything. So essential in order to eliminate cognitive waste is to have QA processes that you can trust on and that are easy to run for anyone. There's a related form of waste, which is code inventory, code that has been written, created, but not yet fully utilized, not yet put into production, or not yet tested by all of the tests that can possibly test run this or find bugs in this code. And there's the American Californian giants are really good at handling cognitive waste and also to handle this code inventory. So we in Europe have lots to learn from them, from their culture. This is a snapshot of a screenshot of the website trunkbaseddevelopment.com, which is one of the methods they use to minimize code inventory and standardize QA processes and so forth. So delivery waste is the waste in the time, the effort it takes from your idea to crafting that down and to put it into production. There are things that you need to do. You need to research and you need to write code and then design and write tests and so forth. But then you do things that are not absolutely necessary to do. For example, you wait for people, you synchronize, you go through some mandatory process and so forth. And in general, if you have more than 10% positive engineering, you are very, very good. Usually the waste is much, it takes up the majority of the time. And I find that once you learn to see waste in these processes, you see it everywhere in the companies you pop into. And the waste is usually introduced by different assumptions. We've always done it this way, and surely security must look at it, or this must go through the staging environment first, or checklists and so on and so forth. And in many cases, it turned out that this is not necessary, in particular not in data processing. But these checks and balances are still there for fear of breaking things. It turns out, however, that this fear and having these checks and balances actually don't make systems more robust and resilient. And this is nowadays proved by scientific research presented in this DataOps report and the Accelerate book, which I recommend everyone to read. It turns out that the companies that move the fastest and have the shortest time to deliver and putting things in production also have the most robust systems, because the ability to throw things out quickly and fix things is more important than prudence. So there's another form of waste which I call data inventory, which is data that we have collected but we have not yet fully processed. So there's still processing yet to be done. And when there's things yet to be done, there are things that can go wrong. And in a traditional environment where you put data in databases, and then at one time, for example, when the user requests his latest orders or whatever, you do the processing, you do the join, and you massage the data to sort of display it to the user. Now, if there's a problem here, like the user has changed his display name to include an emoji or something that you hadn't thought about, so it will break your system, then you notice this at runtime, or the user notices this at runtime. Whereas if you did the same processing eagerly before offline in a pipeline, you will notice earlier. So by processing earlier offline, we can eliminate waste, and we essentially create the equivalent of what in the Toyota production system is called an and cord. This is a way to stop the pipeline, to stop the factory line from causing problems downstream when you know that you have a problem. I see, having worked with big data for quite a long time now, I see lots and lots of technology waste. Many projects drown under heavy technology. It used to be the case that there was so much focus in big data about technology and with Hadoop and other things, but you don't actually need most of the new technology. You only need very few things. You need some file storage, compute, relational database, a little bit of version control, visualization, and then something called workflow orchestration, which is an automation for your operational, to eliminate operational waste, which we'll look at later. There are lots of other things that they may be the right thing for you. They may add value, but they are not strictly essential and necessary, and they are not in general disruptive for what you aim to do. And there is much potential in just cutting things out and removing as much technology as you can possibly get away with. So operational waste is when the things that you have to do in order to keep your systems running, or in order to launch new things in the systems and so forth. And those operational waste kind of fall into two categories. One is friction in the things that you want to do. And this friction is usually caused by fear. You need to be prudent so that you don't break things. And the other thing is when things go wrong, the operational things that you have to do in order to recover, to repair from the problems. And the fear of mistakes is caused by the cost of incidents, right? Your fear of causing incidents. So if we bring the cost of problems way down, really low, the operational waste goes down. How do you do that? Well, we recognize that data processing is an offline thing. It is usually data processing does not immediately affect users or the factories or whatever we have out there. It's computations that we do offline to potentially be used or for insights and so forth. So if we carefully separate the online from the offline, we can move much faster in the offline and not have fear, because the incidents are much cheaper to recover from. So in this example, if we take the orders from an e-commerce store and carefully copy them to the offline without disrupting the online, then we can crunch and do wild and crazy things. And then when we have something like a fraud model, for example, we carefully copy it without disrupting the online. And you see that there are multiple fraud models there, because we are very careful so that if the one that we produce is bad for some reason, we don't overwrite the old one. We keep a few of the old ones to run. So we carefully hand off to online again so as not to disrupt it. And it turns out that online systems, in order to be robust, you need to have lots of nines in each of the components, right? Very high reliability in each of the components for the whole system to be reliable. And operating things with many nines is expensive. That's well known. Whereas at the other end, if you do offline slow processing batch systems, then you have time to recover from things and you can retry again and so forth. And that workflow orchestrator that I mentioned earlier, it's very good at automatically retrying things for you. So tying a system based on weak components together to form a resilient system. And so if you can get by not with so many nines, but with a couple of sevens, then you can have a much cheaper system and do much more complex things and save your operational overhead for data innovation instead. Turns out that stream processing is somewhere in between. It's much more operational heavy than batch, but less so than online, the traditional microservices, because in stream processing, the data only goes in one direction. So you have some kind of chance to like recover by replaying things. Now, every once in a while, I meet people and they say their batch systems are so fragile and they break all the time and so on and so forth. They don't have to be. That means you're doing something wrong. You're probably deviating from the good principles of batch systems. So but I have lots of other presentations that I made previous on how to make your batch systems resilient. So look at my other presentations for advice in that case. So moving from the technicalities, I also frequently see product waste, where we're not building the right thing or not building the things in the right way and so forth. And this is often the case either of work not being driven by pull in Toyota speak, by a stakeholder saying, I want this because it will be valuable, or that there's too much friction, so the stakeholders cannot get what they need. Or that we have a disconnect between the communication so that we're building the wrong thing. And I have two pieces of advice here. One is the data democratization, like really making data and the ability to process available to everyone within the organization. Because if the stakeholders need something, they can build it themselves, and then they will build the right thing. And the other piece of advice is to form teams not aligned with functionality, but aligned with value flow. So there are a few hands-offs along the path to success. So, leaving waste a bit, one of the principles in the Toyota production system is to have a continuous improvement and a learning organization. And some key advice here is one is to not think in terms of projects with the limited, where you do something for a limited time and then it's done, but to think in terms of products that have data products that are never ending, right? They're never done. They're always improving, and improve iteratively and so forth. And in order to iterate, you need to learn, and you can only learn in production. So go to production early and try to minimize the fear of going into production with your data pipelines. And they expect to fail, so you cannot have shame or blame or penalties for people failing, and so forth. So quality assurance is different for data products, and in traditional products that are not sort of data-driven, their quality only depends on the code, right? And Apple is an example of a company that really excels at making these products. You get this thing in your hand, and it's polished. The code of the product is polished to perfection, and it's fantastic. Whereas data-driven products are their quality is dependent on code, but also on the data. And it turned out that the processes suitable for making the Apple-style products are not so great for making data, because you need to learn from the data. It's volatile, it's organic, it changes all the time. And we saw that when Apple Maps was launched, and the quality was absolutely terrible. But you can, how do you test them and do quality assurance? You can only do that in production, because that's where the real data is. So that's why you need to get out into production quickly and not spend your time on the way there. So, which leads us to another form of waste, which I see fairly often, which is infrastructure waste. Since you need to learn in production, you only need a production environment. You don't need the dev environments and the test environments and the staging environments and so forth. That doesn't mean that whenever you do a change, you immediately do it on one of the highly valued, very important pipelines. You can have so-called dark pipelines where you run a separate copy of your pipeline in parallel with sort of new experiment, new features. But you run it in the production environment, so that it gets the real production data, and then you compare with the output with the sort of the baseline, and if it's good enough, you launch it, or maybe you launch a little at a time with an A/B test, and so on and so forth. And that's how we sort of have, you can call them staging pipelines if you want. This is an example I saw on the wall of a company I visited, where there's absolutely no space for learning. This is a sort of pure waterfall model on how to launch a use case in their lake. And I don't know if you can read properly, but the phases include like two committees for deciding go or no go, 2 phases of data governance and requirements collection, and so on and so forth. And this company is, or these teams at least, are apparently very scared of writing the wrong lines of code, which is completely the other way around, right? You should be scared of everything else, because that's the waste. You should try to get to the code and get something out there as quickly as possible. Once you've gone through this cycle, it takes at least 6 months. Then you're so exhausted that there won't be any time for learning. So processes like this is the very sore end of the spectrum, and the processes like we saw in Discovery Weekly is the end of the spectrum where you want to be. So I hope you got some good advice on how to make your data processing lean in order to implement great DataOps. If you want to learn more, this is a handful of books. I've spoken about a couple of them. The one to the left is the best book description of DataOps that I found by Harvinder Atwal. And the one to the top is Data Kitchen's blog. Data Kitchen is a company based in Boston, and they have great resources on DataOps. It's also a company built around DataOps. If you want more practicalities around DataOps and on how to sort of do it in practice, my presentation from Data Innovation Summit 2 years ago is a good starting point. I promise to tell you something about what Sling is doing. So I have spent a number of years as a freelancing consultant trying to help companies build up data processing capabilities and get more value from their data and so forth. And I've helped them build technology, but it doesn't really make any significant difference in most cases, because they need to change the way they work in order to get value from data. And changing how people work is really, really hard. and takes a long time. So we have a different model now where we collaborate closely with the customers, but we do the implementation, the building the pipelines, we host them, we run them for the customers so that we implement the right ways of working with data. And customers can work closely with us because we need their collaboration. They have the data, they have the domain expertise, so we work in joint teams, and they can learn by doing with us rather than us go the other way around, us going into an organization and trying to fit them. So time will tell whether it's usually successful or not, but this is what we're up to, and I believe that we need to find new ways of collaboration because the current ways of collaborating with each other are not working sufficiently well. There's so much unused potential and so much waste out there. Thank you for listening. I hope you have a great conference.